Solve problem on inventory model 2B for which demand rate uniform, replenishment rate infinite, shortages allowed, time interval fixed by using important formulas. Let us understand some important formulae related to inventory model 2A. Inventory model 2 is under the category of elementary model with deterministic, that is constant demand, and shortages are allowed. For inventory model 2A, demand rate is uniform, replenishment rate is infinite and fixed time interval. Let us understand all these characteristics with the help of graph. On vertical line we have to show inventory level, and on horizontal line we have to show time. Now interval in between two orders is fixed for this model 2B. So we will show here the fixed interval T. So we will consider O will be the initial point or the point at the beginning of the interval T, and here at this point D there is we have to place the second order. Now we will move to the other parameters. So here R is the demand rate and IM is the number of items that form inventory at the beginning of the interval T. So point O is the initial point for this interval T. Now at this point O there is some inventory available. So we will show here this particular level, and that level will be IM. So I will show. So here is IM, and I will show this point as a point A. Now this initial inventory is available and there is demand rate or consumption rate is uniform, and this demand rate we have to show with letter R. So we will show with the constant slope, and I will show this. Here is the R. Now what is happening when this slope reaches to this point? We will consider this point as a point B. Inventory becomes 0, and after that shortages occur. So what is happening? So when shortages occur, customers leave their orders with the suppliers, and shortages starts piling up at constant rate R. So here the demand rate or consumption rate remains same. So we will continue this slope R up to the interval T. So if we observe here, this is the point D, and at this point D we have to place the second order because this time T is fixed. So if I draw one vertical line passing through the point D in the form of dash, then point of intersection of this slope and this vertical line passing through point D is point C. And at this point C we have to place the next order. So the distance in vertical distance in between C and D is that the shortages are filled up, and we will show the shortages with letter S. So the vertical distance is known as with letter S, and after that the inventory is available for the next cycle. So here the same level we have to maintain. So I will draw here one horizontal line, and from this point D we have to draw one vertical line. So this vertical line I will show here as a point E. So up to point E, that is D to E, this inventory is available for the next cycle. So one cycle starts from this point O and it ends at the point D. So time interval in between this time interval T is divided into two parts, that is from O to B. So from O to B that will be T1, and at this point B inventory becomes 0, T1, and after that from B to D this time interval is known as T2 because this is the time interval for the shortage. Now we will understand the remaining parameters. So C1, that is the cost of holding per item per unit time. C2 shortage cost per item per unit time. C3 ordering cost per order. Now we know that orders are placed within fixed interval of time. So this T is fixed and that's why ordering cost is also constant. Then Q, number of orders ordered. Now at this point C, order is placed up to point E and this total order is known as Q. So I will draw here one vertical line from this point C up to point E and this inventory level is known as Q. Now how to show this point Q? So if we observe, here is this total slope, that is from A to C is R and the distance from this O to D is T. So this R multiplied by T is equal to Q. So we can say that Q is equal to R into T. So this is the diagram. Now we will understand the formula related to inventory model 2B with the help of diagram. Now this total time interval T is equal to T1 plus T2 and this time interval T is fixed. Now how to write this T1 in the form of T? So for that we will refer these two triangles, triangle OAB and triangle PAC. Now we will take the ratio of base, that is T1 by T with ratio of height, that is equal to Im by Q. So we can write here T1 is equal to Im into T by Q. Now in the same way we will write this T2 in the form of T. Again we will take the ratio of two triangles, that is we will refer two triangles, triangle BDC and triangle AEC. Now we will take the ratio of base, that is T2 by T, because AE is equal to PC. So T2 by T is equal to this height S divided by Q, this height CD divided by CE, that is S divided by Q. Now this S we can write Q minus Im, because if we observe the difference between Q and Im is nothing but S. So we can write T2 is equal to Q minus Im into T divided by Q. Now total inventory in time T. So if we observe, up to this point B only inventory is available. So total inventory in time T is area of triangle OAB. That is equal to half multiplied by this base multiplied by half height, that is half multiplied by T1 into Im. Now inventory holding cost during time T. So inventory holding cost, that is holding cost multiplied by the total inventory. So holding cost is C1. So half multiplied by Im into C1 into T1. So I will take here the equation number 1 because this is the first cost, that is the holding cost. So we have to multiply this total inventory with C1. Then total shortage cost during time T. Sorry, here this total shortage. So how to find out the shortage? So here the area of triangle CBD is nothing but for shortage. So I have shown here with the help of red marker. So what is this area? That is half multiplied by this height. So height is Q minus Im and multiplied by this T2. So instead of S we will write Q minus Im. So shortage cost, multiply this with shortage cost C2. So shortage cost is equal to half into C2 into Q minus Im T2. So here will be equation number 2. Next is ordering cost during time T. So ordering cost is C3 and we know that this T is also constant and therefore C3 is also remains constant. Now we will find out what is the total cost during time T. So I will write here the equation 3 for this ordering cost. So what is the total cost during time T? So we have to add these three costs. So I will add this, that is half Im C1 T1 plus half Q minus Im C2 T2 plus C3. Now we will write what is the total cost per unit time. So I will write here the total cost per unit time. So how to calculate this? So we have to divide this whole equation with T. So for this first two terms, I will write the bracket, square bracket, and I will write here 1 by t. And here plus C3 divided by t. Now we know that C3 is constant and this time interval t is also constant. So for this inventory model 2b, because this whole term is constant, so we should not consider this. So we have to consider only this for the total cost per unit time. So I will remove this. So this is the formula. Now we will write this formula in terms of Q. So how to write? So I will write this T1 and T2 in terms of Q from these two. So I will write here total cost per unit time is equal to. Now I will write half Im C1. Now T1 we will write here Im by Q into T, but here outside the bracket 1 by T is there and Tt is getting cancelled. So instead of T1 I will write Im by Q, but Im is already present, so here will be Im square by Q plus next half Q minus M C2, and instead of T2 we will write Q minus M by Q into T, but here outside the bracket 1 by T is there, so this Tt is getting cancelled, and T2 we will write Q minus M by Q, but here Q minus M is already present, so I will write Q minus M square divided by Q. So this is the formula that we can also refer, that is half Im square by Q C1 plus half Q minus M square by Q C2. Optimum value of Im, that is IMO, is equal to C2 divided by C1 plus C2 into Q. So how to write this Q? So Q is nothing but R into this T. So Q is equal to RT, we can replace here. Then minimum average cost per unit time. So minimum average cost, that is optimal cost, CO is equal to half C1 C2 divided by C1 plus C2 into Q. So we can replace this Q with RT. Given question, a contractor supplies diesel engine to a truck manufacturer at the rate of 20 per day. He has to pay a penalty of rupees 10 per engine per day for missing the scheduled delivery date. Holding cost of a complete engine is rupees 12 per month. The manufacturing of engine starts with the beginning of the month and is completed at the end of the month. What should be the inventory level at the beginning of each month? Let us understand the given data. Consumption rate R is given 20 engines per day. Penalty for missing delivery date. So here penalty for missing delivery date, that means shortage cost C2 rupees 10 per engine per day. Holding cost C1 rupees 12 per month. So if we observe the unit, here unit is month, so we will convert it into days. So in 1 month there are total 30 days. So what is the cost in 1 day? So 12 by 30, that is rupees 0.40 per day. Then time interval T is given 1 month, that is we will again convert this into number of days, that is 30 days. Now if we observe the question, inventory at beginning of each month. So each month is important, that means here time interval T is fixed. So we will take here this T is fixed. So whenever this time interval T is fixed, that means question is under the model of 2P, that is demand rate uniform, replenishment rate infinite, and fixed time interval. So we have to use the formula for fixed time interval. So from this diagram, inventory at beginning of each month. So T is the 1 month period and inventory at the beginning of T. So this is the initial point and inventory level at this point is nothing but Im. So we have to find out this Im. So we will find out the optimal inventory, maximum inventory size, that is IMO, which is equal to C2 divided by C1 plus C2 into Q. Now what is the value of Q? So this Q is equal to this R into T. Now R is given 20 engines per day and T, time interval T is fixed and it is 30 days. So we will take here 20 into 30. And what is the value of C2? It is 10 divided by C1, that is 0.40 plus 10. So when we solve this, we will get the answer 577 engines per month.